Welcome to another chemistry session with Ms. Taylor. The subject of this video is single displacement reactions. And pretty much, how do you know a reaction is actually going to happen? But before you can predict a reaction, you need to be able to recognize a single displacement reaction. A single displacement reaction always has an element and a compound on both sides of the arrow. So, why is it single displacement? Because there is one switch. The single element is going to switch places with one of the elements in the compound. Now, in case you're trying to remember, well, how can I tell which one's the element, which one's the compound? Remember that a compound has to contain two or more different elements. Now, make sure you recognize diatomic elements. And diatomic elements are those elements that appear in nature as always two atoms together. Okay? They're still not a compound because it's not two different elements, but you should have these memorized. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay? So memorize these. So the question is, how exactly do you predict a single displacement reaction? We use something called the activity series. And there are 4 questions that you can answer using the activity series, because really there are 4 types of single displacement reactions. So there is, will the metal react with water? Will the metal react with acid? Will a lone metal replace the metal that's in part of the compound in solution? And will the lone halogen replace the halogen that's part of the compound in solution? And in case you don't remember what a halogen is, halogens are all the elements in group 17: fluorine, chlorine, bromine, and iodine. Now, what is this activity series that I'm talking about? Okay, here is the activity series. Okay, notice there's an activity series for metals and an activity series for halogens. Okay, so as you go down the list, the metals become less reactive. So the most reactive metal is lithium. The least reactive is gold, which is why we use gold for jewelry. And then there's a separate list for halogens, which actually matches the order they are down the column in the periodic table: fluorine, chlorine, bromine, iodine. Also notice you've got these little boxes out to the side, and this is divided into sections. Okay, so for the top section, you read the note and it tells you about extra things to know. Remember those questions we were looking at? Will it react with water? Will it react with acids? So we'll come back to this. So we're going to look at an example of each type. Alright, so question 1 was, will the metal react with water? And you need to read the note on the side. Okay, so let's look at the different notes so we can check this. Whoops. Okay, notice in this first section it says react with cold H2O and acids. Now, when it says cold H2O, what it really means is water at any temperature. React with steam, from magnesium to cadmium. That means these will not react unless it is water at 100 degrees Celsius or higher. Once you get past cadmium, these do not react with water at all. So let's look at some examples using the activity series with answering this type of question first. The first reaction I'm going to look at is going to be solid lithium metal and liquid water. Actually, let's not do liquid water. Let's do solid water. Solid water would be ice. So if we go back to our note on the activity series, lithium reacts with cold water, which means water at any temperature, including ice. Sorry, this thing keeps scrolling back. So a reaction will happen, and your activity series tells you that it replaces hydrogen. Now, there's another quick way for you to be able to tell which elements switch places. Look at the charges. Lithium is a +1 whenever it forms an ion. Hydrogen's a +1 and oxygen's a -2. You know that you can only make an ionic compound from oppositely charged ions. So the ones that have the same sign are going to be the ones that switch places. But the activity series also tells you that it replaces hydrogen. So if it replaces, it switches places. So what you're going to get, the replaced element is going to be by itself. So you're going to have hydrogen and a compound of lithium and oxygen. Okay, now I specifically wrote out the words first to draw your attention to the fact that you have to write correct formulas. Okay, hydrogen is one of the diatomic elements you're supposed to have memorized. So you would write H2. I'm going to come back to the state. And then a compound made from lithium and oxygen. Lithium is a +1, oxygen is a -2. Remember to swap, drop, reduce, so you would need 2 lithiums to 1 oxygen. So the correct formula for the compound form is Li2O. Now, what about the states? Okay, if it's a pure element, you just look at the periodic table. And the periodic table will tell you that hydrogen is a gas, so you would put G. But this is a compound. For compounds, you have to check your solubility rules, which I have over here. Okay. And we were looking at lithium oxide. Lithium is a group 1 metal. And under soluble, all group 1 metal compounds. So if something is soluble, that means it's dissolved in water, and the word for that is aqueous, and we indicate that with an AQ. So here we would write AQ. Now mind you, this equation is not balanced. I'm not worried about balancing them right now, but just in case you wanted to balance it, you would need a 2 right here. So let's look at another example with a metal and water. What if we had solid calcium in liquid water? Let's check our activity series. Calcium reacts with water at any temperature. So a reaction will take place, hydrogen will be replaced by calcium. So hydrogen by itself, diatomic element, and it's a gas. Then we have to make a compound out of calcium and oxygen. Well, calcium is a +2 and oxygen is a -2. So that means you only need 1 of each. So the formula would be CaO. Now, we don't know if that's going to be aqueous ions or solids, so let's check our solubility rules. Insoluble. Oxides are insoluble except group 1 metals, calcium and barium. So according to this, calcium oxide is actually soluble. So we will indicate aqueous for that state. And I apologize that my program is not keeping my place. Next example, let's look at aluminum, which is a solid, and liquid water. Now I'm sure if you think to yourself, if I put a piece of aluminum foil into a glass of water, nothing's going to happen. Well, if we check our activity series, we see that that's true. Aluminum will only react with water when it's in the form of steam. So liquid water is not hot enough. So this one would be no reaction. However, if you were given aluminum metal plus gaseous water, which is steam, we just saw that there will be a reaction, so you would have hydrogen gas released, and then your aluminum and your oxygen will hook up. Now, aluminum forms a +3 ion and oxygen forms a -2. So the correct formula would be Al2O3. Now, we don't know if this is going to dissolve or what. So let's check our solubility rules real quick. Back to oxides. Oxides are insoluble with a couple of exceptions. Aluminum is not an exception, so that's actually going to be a solid compound. So this will be a solid. All right, our second question is, will a metal react with an acid? Again, you need to read the notes. Now, how can you tell if it's an acid if I don't say specifically in the question it's an acid? Well, acid formulas start with H. For example, hydrochloric acid is HCl. And on the activity series, if the note does not mention an acid, then it does not react. So, let's do an example of calcium, which is a solid, plus nitric acid. And all of the acids you tend to deal with as far as in this type of reaction are going to be a solution. There are some solid acids, but we're not going to deal with that. Now, if you check your solubility rules, excuse me, not your solubility rules, your activity series, calcium does react with acids, replacing hydrogen. So your product would be hydrogen, which is diatomic, and a gas. And then you would have to make a compound from calcium and nitrate. Now, since calcium's a +2 and nitrate's a -1, it's going to be Ca parentheses NO3 parentheses 2. And if you check your solubility rules, all nitrates are soluble, so that one's aqueous. Another example, what if we were to drop solid zinc metal into hydrochloric acid? All right, if you check your activity series, zinc does react with acids, replacing hydrogen, so your products would be hydrogen gas. And then something made from zinc and chlorine. Zinc is a +2 and chlorine's a -1. So the formula for your compound would be ZnCl2. And then if you check your solubility rules, chlorides are soluble with a few exceptions. Zinc is not an exception. So that would be aqueous. Again, I'm not balancing these right now. We're just predicting products. What if we dropped a piece of copper into sulfuric acid? According to the activity series, copper does not react with acids, so this would be no reaction. Now, in reality, if you had very concentrated acid, the copper would react, but that's a special situation for an upper level chemistry class. We are just following the activity series. One more example. What if you had silver metal and hydrobromic acid? If you check your activity series, silver does not react with acids, so again it would be no reaction. Alright, let's move on to question 3 that we can answer. I have to apologize that you can't quite see this. Let me fix this real quick. Will the lone metal replace the metal that's part of the compound in solution? For this to happen, the lone metal has to be higher in the activity series than the metal in the compound. So let's look at some examples of that. What if we dropped solid barium into a solution of aluminum chloride? What you're asking yourself is this higher than this? Now if we check our activity series, barium is higher than aluminum, so barium will replace aluminum. So the metal that is replaced now is by itself, and aluminum is a solid. And then you have to make a compound out of the barium and the chlorine. Barium is a +2 and chlorine is a -1, so the formula will be BaCl2. And when you check your solubility rules, barium chloride is soluble, so we put aqueous. Next example, manganese solid and potassium bromide solution. So you're asking yourself, is manganese higher in the list than potassium? If you check the list, potassium is higher, so this one is no reaction. One more. Let's put solid magnesium into a solution of lead 2 nitrate. So you're asking, is magnesium higher in the list than lead? And magnesium is higher in the list, so lead is now going to be by itself, and it's a solid. And you're going to make a compound out of magnesium and nitrate. And since magnesium is a +2 and nitrate's a -1, the formula would be Mg parentheses NO3 parentheses 2. And all nitrates are soluble, so this would be aqueous. Moving on to our last question, our last type of single displacement reaction. Pardon my screen did not keep things in exactly the order that I had them in previously. So the last one is similar to the metal, except this time we're looking at a halogen, and remember that halogens are group 17 elements. So let's say fluorine gas is bubbled through a solution of potassium bromide. So you're comparing fluorine and bromine. If you look at your activity series, fluorine is higher, so bromine is now going to be by itself, and bromine is a diatomic element, and if you check the state on the periodic table, it is a liquid. And then you're going to make a compound out of potassium and fluorine. So +1 -1, it is Kf, and all group 1 metal compounds are soluble, so it is aqueous. In example 2, what if we dropped solid iodine into a solution of sodium chloride? We're comparing iodine and chlorine. You're comparing the two halogens. And remember, even if you don't recognize it, look at the charges. You're comparing the ones that have the same sign. So you're comparing the two negatives to each other. Now, iodine is at the very bottom of the list, so this is no reaction. What if we bubbled chlorine gas through a solution of sodium iodide? We're comparing chlorine and iodine. Chlorine is higher in the activity series than iodine, so a reaction will happen. So iodine is now by itself, and it's one of the 7 diatomics. And if you check the periodic table, it is a solid. And then we make a compound from sodium and chlorine. You've got a +1 and a -1, so it is NaCl. And all group 1 metal compounds are soluble, so it is aqueous. One more. If we poured bromine, which is a liquid, into a solution of lithium iodide, would there be a reaction? You're comparing bromine and iodine, and bromine is higher in the list. So iodine will be replaced, and remember it's a solid and diatomic. And then you would have a solution of lithium bromide because all group 1 metal compounds are soluble. So there's our 4 types of single displacement reactions. Remember to check your activity series, and good luck.